Let's talk for a minute how objects get allocated into memory. It's all well and good to declare a new class with instance variables and methods and to write the code for these methods, but the next step is to give birth to an object based on the new class, which happens at runtime. At runtime, a class object for each class is automatically created, one that knows how to build new objects belonging to the class. The class object is the compiled version of the class. The objects it builds are instances of the class. These instances are the objects that do the main work of your program. Think of the class definition as really a prototype for a kind of object, not the object itself. Here is the class definition in main_view_controller.h. The class definition declares the instance variables and defines a set of methods that all objects in the class can use, in this case, the showInfo method. The objects you give birth to are instances of the class. To give birth to an object in Objective-C, you must do the following. You must 1. Dynamically allocate memory for the new object, and 2. Initialize the newly allocated memory. Let's look at the implementation file. Here we see an object, flip-side view controller, being allocated. The object isn't fully functional until both steps have been completed. Each step is accomplished by a separate method, but is typically carried out in a single line of code, as shown here. You see the alloc statement here, and the init statement, actually init with nibname, here. Allocation, or alloc, starts the process of creating a new object by getting the amount of memory it needs from the operating system to hold all the object's instance variables. As you recall, NSObject is a root class that defines the basic framework for all the Objective-C objects that you use and their interactions. The alloc method is one of the principal methods of NSObject for allocating memory. The alloc method allocates enough memory to hold all the instance variables for an object. Separating allocation from initialization, as we do here with alloc and init with name, gives us control over each step so that each can be modified independently of the other. Initialization is a very important part of working with objects. In many cases, you don't need to initialize all your instance variables. If you can live with all the instance variables initialized to 0 and nil, which is nothing, you don't need to do anything. But if your class or your superclass has instance variables that you need to initialize to anything other than 0 or nil, you're going to have to code some kind of initialization method. The showInfo method here initializes the flip-side view controller with nibname method. And this happens when the user touches the I information button. It also initializes the flip-side view nib file, which is called flipsideview.xib here. This is the flip-side view. We'll close the builder doc so you can see it better. As you recall, mainView.xib has the I button that the user clicks to get to flip-side view. This is handled here in the showInfo method. While initializing the flip-side view, the showInfo method sets the controller modal transition style to UI modal transition style flip horizontal. That's what creates the slick animated flip transition while opening the flip-side view. Let's take a look at flip-side view controller's header file here. The UI view controller protocol is used for flip-side view controller. As you recall, the UI view controller class provides the fundamental view management model for all iPhone applications. And in the implementation file for flip-side view controller.m, we see a method called viewDidLoad. This is most commonly used to perform additional initialization steps on a view loaded from a nib file before displaying the view. In this case, it sets the view background color to UI color view flipside background color, which is the system color used for the backside of a view while it's being flipped. Let's talk for a minute about how messages get sent to objects. To get an object to do something, you send it a message telling it to apply a method. In Objective-C, message expressions are enclosed in brackets, like this one. The receiver is an object, in this case super for superclass, and the message tells it what to do, in this case viewDidLoad. In your code, the message is simply the name of a method and any arguments that are passed to it. When a message is sent, the runtime system selects the appropriate method from the receiver's repertoire and invokes it. This code sends the message viewDidLoad to the superclass, which is UI view controller. As a result, you get a flip-side view. Of course, thanks to the utility template, all of this code is provided for you, and all we need to do is modify it.